Hello, this is Mr. Waters, and I have got another example here from page 679 on homework, and this has to do with graphing parametric functions and then converting them into rectangular form. So first off, a parametric function is one that looks like this. X is equal to, here's an example of one, x is equal to 3t plus 1, and y is equal to opposite t minus 2. Parametric function is it's basically an ordinary function made up of x, y ordered pairs like usual, but instead of the y value being defined in terms of an x with the equation, or the x being defined in terms of the y, each of the two variables, x and y, are each defined separately, independently, in terms of a third variable t, which is called the parameter. The parameter, that's t. We don't have to use t, it's just that that's usually commonly what's used. Now another feature of parametric functions is that the parameter is given an interval, is defined with a specific interval. So for example, t could be set greater than or equal to 0. Now why you do that has to do with what parametric functions are for and would be specific or characteristic of the particular situation in which you're using the parametric functions. For example, so in this case, t, for example, might be time, and so time has to be either 0 or greater, so we would define t to be greater than or equal to 0. So to actually graph this function, we're going to go ahead and we're going to make a t-table. Okay, and there's the first column. That's not very straight. The first column will be for our values of t, which we'll pick. The second, which is for our function 3t plus 1. And the third, which is opposite t minus 2, which is what y is equal to. So we'll pick some values for t. Let's say 3, because the parametric equations are linear. I'm going to pick a 0 and a 1 and a 2. So for the first parametric equation, that's the x1, we're going to put 0 in for t. 3 times 0 plus 1, well, that's 1. And then we put 0 in for y. Into the y, that's opposite 0 minus 2 is equal to negative 2. So that means the ordered pair 1, negative 2 is part of our function. So now for the second value of t, we put that in. 3 times 1 plus 1, that's 4. Negative 1 minus 2, that's equal to negative 3. So that would mean that in our function here, 4, negative 3 is an ordered pair. And then we put the third value in. 3 times 2 plus 1, that's 6 plus 1 is 7. And then negative 2 minus 2, that's negative 4. So the ordered pair 7, negative 4 is part of our function. Now we go ahead and we graph those 3 points. 1, negative 2. 1, 2, 3, 4, negative 3. And then 4, 5, 6, 7, negative 4. Which is down here, and those make a nice straight line. So there's the graph of the parametric function, which keeps going forever in the positive x direction, but which starts with a point there because that's where t is first defined at t equals 0. Okay, now the second part of this, so this is number 1. There is our graph of our parametric function. Step 2, or part 2, we want to be able to convert this whole parametric function into one single xy equation, which is the rectangular form. The way we do that is we take the first one, which is the x parametric equation, x is equal to 3t plus 1, and we solve that for t. Why? Because the t in the first equation is equal to the t in the second equation, and we'll just substitute. Okay, so we subtract 1 from both sides and get 3t is equal to x minus 1, and then we divide everything by 3 to isolate the t, and we get t is equal to 1/3 x minus 1/3. Now, this t is the same as the t in the y equation. So I'm going to start with the y equation here. Y equals to opposite t minus 2. I'm going to take this entire t expression from the x parametric and substitute it into the t in the y parametric. And then we'll simplify. Y is equal to opposite 1/3 t minus 1/3, and then minus 2. Now we just simplify that. We distribute the negative in, so y is going to be equal to negative 1/3 t minus negative is, or minus negative is plus 1/3 minus the 2. So we combine the like terms, that's negative 1/3 t minus 1 2/3. Okay, now we look over here. So this is, okay, that's the rectangular equation that's equivalent to this parametric function up there. It names the same set of points. Its graph is the same. And we can see, going back and looking at the graph we already made, that first off, that were we to extend this, we can see the y-intercept is going to be about negative 1 2/3, and that the slope here is over 1, or rather down 1 over 3, down 1 over 3, which is, of course, the slope of negative 1/3. Anyway, so there it is. There is the graph of your parametric function, and there is its rectangular equation equivalent. Thanks for listening.